Hello everyone. In this video, we're going to be utilizing identities to find the sine and cosine for the double angle 2x, given that tangent of x is 4 and the cosine of x is positive. So basically, we need to know our double angle identities so that as a starting point to see what we actually need to find. So we know that for sine of 2x is 2 sine x cosine x, and for cosine we have three versions of the identity. Cosine of 2x is either cosine squared x minus sine squared x. That's one version. The other version is 2 cosine squared x minus 1. And the last one is 1 minus 2 sine squared x. Now, when I know the tangent, and if I also know the trigonometric identities known as Pythagorean identities, I should be able to find the secant. So let's go back to those Pythagorean identities really quickly. We have sine squared x plus cosine squared x equals 1. If you divide both sides by cosine squared, you end up with tangent squared x plus 1 equals secant squared x. And if you divide both sides by sine squared, you end up with 1 plus cotangent squared x equals cosecant squared x. Of interest to us right now is this one, because from that we can get the secant, which means we can get the cosine. So we go ahead and use that. So we have tan squared x plus 1 equals secant squared x, and we go ahead and substitute 4 for tangent of x, so we get 4 squared plus 1 equals secant squared x. So we have 17 equals secant squared x. So applying square root property would normally give us plus or minus, but because the cosine, as we can see, is positive, we're only going to take the positive case. But also, we might be better off if we actually turn this into a cosine expression before we continue. So what I can do is, since secant squared x is 17, I know that cosine squared x is going to be 1 over 17. So now I will take the consideration that cosine is positive to determine that cosine of x must be 1 over positive 1 over square root of 17. So notice that if cosine of x is 1 over square root of 17, we usually like to rationalize that by multiplying by square root of 17 over square root of 17. So we end up with cosine x equals square root of 17 over 17. Now, at this point, we know the tangent and we know the cosine. So finding the tangent, the sine should be easy, because that's one of our main identities. We know that the tangent of an angle is the sine of the angle divided by the cosine of the angle. So if we solve this equation that I just wrote down, think of there as being a 1 there and cross multiply, so you get sine x equals cosine x tangent x. So that means we can go ahead and find sine x by multiplying cosine x, which we now possess, by tangent x, which we also possess. So we end up with cosine x, which is square root of 17 over 17 times the tangent x, which is 4. So we end up with 4 square root of 17 over 17. That's sine x. So now we have everything we need in order to find both sine 2x as well as cosine 2x. So for sine 2x, we need 2 times sine x times cosine x. So it's going to be 2 times 4 radical 17 over 17 times the cosine of x, which is square root of 17 over 17. So we end up with 8 times 17 over 17 times 17. So we notice that one of those 17s can cancel out, and we just end up with 8 over 17. And remember that that was sine of 2x. All right, so the last thing we need to find is the cosine of 2x. We actually have enough information to use any 3 of those forms, right? So I'm just going to go ahead and go with the second one. That seems to be a fairly easy one to use. So cosine of 2x is going to be 2 cosine squared x minus 1. So it's going to be 2 times I'm going to use this form. That's the simplest form to square. So I could have used this form as well, but that's a little bit easier to square. So 1 over square root of 17 squared minus 1. So 1 over square root of 17 squared is just going to be 1 over 17. So we get 2 over 17 minus 1 over 1, which of course we can quickly combine those fractions by multiplying top and bottom by 17. So for the final answer, we will end up with negative 15 over 17. And recall that we started here, so that was cosine 2x. And that's how we can use identities to evaluate a request like that one. All right, so I hope that helps out, and be safe until we meet again.